On the morning of September 1, 1859, something extraordinary happened, something that had never been seen before by human eyes. British astronomer Richard Carrington, while sketching sunspots during his routine solar observations, noticed a sudden and dazzling burst of white light erupting from the surface of the Sun. Unknown to him at that moment, he had just made the first recorded observation of a solar flare. This was not just a visual oddity. It was the beginning of an astronomical and scientific awakening, one that would reveal the powerful and sometimes dangerous relationship between the Sun and Earth. Carrington, along with another observer, Richard Hodgson, independently witnessed the same brightening of a sunspot region. The phenomenon lasted only about 5 minutes, but its implications were massive. What they had seen was an enormous explosion on the Sun's surface, what we now call a solar flare, caused by a sudden release of magnetic energy. Less than 18 hours after this fiery outburst, Earth was hit by the most intense geomagnetic storm ever recorded. Auroras, normally seen near the poles, were visible as far south as the Caribbean. In Europe and North America, telegraph systems went haywire, sparking fires, delivering electric shocks to operators, and continuing to send signals even when disconnected from power. This solar event became known as the Carrington event. The connection between Carrington's observation and the geomagnetic chaos on Earth was revolutionary. For the first time, scientists realized that solar activity could directly affect our planet. This discovery laid the foundation for the field of space weather, the study of how solar phenomena impact Earth's magnetic field, technology, and atmosphere. The 1859 flare showed that the Sun was not just a passive celestial light bulb, it was an active, volatile force capable of disrupting life on Earth. Today, we know that solar flares are often accompanied by coronal mass ejections, CMEs, vast clouds of charged particles that can cause geomagnetic storms, satellite malfunctions, and power grid failures. Modern space agencies like NASA and the ESA now monitor solar activity 24/7 with satellites like SOHO and the Parker Solar Probe. Their work is driven by the legacy of that first, accidental glance through a telescope nearly 2 centuries ago. The Carrington event remains a stark reminder of the Sun's unpredictable power. If a similar event were to occur today, it could cripple satellites, communication systems, GPS, and even national power grids, causing trillions in damages and affecting millions of lives. And yet, it all began with one man in a telescope, watching the Sun on an ordinary September morning. The first observed solar flare wasn't just a flash in the sky, it was a warning from our star, a cosmic wake-up call, and the dawn of solar science.